Welcome to video number 12. This video is inspired by a toy that my son just got given by our lovely neighbours. They got him a little flower that attaches to the hose and it sprinkles everything. My son loves it. My wife was sitting there thinking, oh, this is going to get water everywhere inside the house. And I was thinking, oh, what a lovely little toy to demonstrate some nice maths results. As it sprinkles around, every now and again it kind of gets to a point where it looks like it's going to be stable and stays there. But the points of equilibrium on this particular toy are unstable. They don't kind of hold their place. If a little bit of wind came along and blows it off, then it starts swinging around again, and that's not good. And that made me think about a particular maths technique which you study at A-level. The technique's called iteration. Most exam boards have it as part of their A2 syllabus, and it's a way of solving equations that otherwise would be very difficult to solve, or maybe you don't have a better technique on how to solve them. It's quite effective. It has its problems, and what we're going to look at is very quickly how to do it. I'll just give you a real simple example of how to do it, and I'll show you some of the issues that can come up, some of the unstable points, like the flower where you try them and it ends up going everywhere. So I'm going to look at an equation that you'll probably know how to solve. I'm going to look at x squared minus 4x plus 3. There's even some people that by this point watching the video will have gone, I know what the solutions are. Well done to you. But at least as long as you have a way of solving that, whether you need pen and paper or not, that's all that matters. Now this way of solving it, you'll not only need pen and paper, you'd also probably want a calculator to do it. And so you might think, well, what's the point? The point isn't obvious from this example, but if we had a harder one, we can use the same technique to solve it. And I'm going to leave you with a hard one at the end of this video. So here's the technique. What we're going to do is arrange it so that x is the subject. Not so x is in terms of other variables, but so x is in terms of x. So one way I could do that is moving these two terms across, which will give me x squared equals 4x minus 3, and then square rooting. So I get x equals square root of 4x minus 3. Now actually I know there's a sign issue with this, and that's fine. I'm not looking for an equation that is identical necessarily to the top. I'm just looking at one that has x at the front. Another way of doing it is adding 4x to both sides. So I'd have x squared plus 3 equals 4x, and then divide by 4. Now the way this method works is it generates a series of results, and the idea is that we pick particular numbers so that the series tends towards an answer that we want. So this series would be the series xn plus 1 equals square root of 4xn minus 3. This one would be xn plus 1 equals xn squared plus 3 over 4. And there's a really neat way of typing these into your calculator. What we need to do is start off with an xn. Start off with a value to start off with, obviously. So I'm going to start off with 2 on both of these. I'll do them separate. I'll show you what I'm typing into my calculator, so you can see the results. So the first thing to do is to type in your starting value. So in this case 2 is my starting value, so I type in 2, press equals, nothing interesting happens. But what I can now do is say that my answer is 2, and that root 4 answer minus 3, like this. So now my calculator will use 2 as part of its calculation, and then work out what the answer would be if the value in there is 2, which is what we want. So it says that's 2.23, or 2.24 rounded to decimal places. So I can say x1 equals 2.24, and I can now just press equals again. It will put the answer as it's the value it's just worked out, so it will work out the next term and the next term. And I'll just work out a few of these, and I'll do the same for the other side and then show you the results. So here's what I've typed into the calculator for the second equation. And there's my two solutions. So some of you would have worked that out from the start. If I just show the original equation again, x equals 3 and x equals 1. Isn't that lovely? That technique works for any polynomial, regardless of how high the order is. But the problem is picking the right starting values and picking the right equation to go with that starting value. So for example, I'll just do one of these. If I picked a starting value of 4 with this one, let's just see really quickly what would happen. So I'll just use a different colour so you see I'm doing something different. So if I start off x0 equals 4 and then go through this process again. Okay, and very quickly, by the time I've done 10 iterations of that, I've got to a number which is, well, very big. 2.31 times 10 to the power 57. That's a pretty huge number, and it certainly isn't a solution to this equation. Going to infinity, my calculator's going to get an error after maybe 1 or 2 more times. Just 1. Okay. So obviously, if you're not sure what solutions you're expecting or how many solutions you're expecting, it can be difficult to ensure that you've found all the solutions. There are ways of going around this, and you'll do this in your maths lessons. There's graphs you can draw. You can use a graphical calculator to help you start off the process, and it's not too bad. And certainly if you get it in an exam, and then they'll give you structure and they'll help you through that process. They won't just give you something like I'm about to and go, see what you can do. However, although you're not expected to be able to do this in an exam, I think it's good fun. Obviously, for those of you that have a different definition of fun as I do, I apologise. Here's the question. Cubic. Those of you that think, oh, I know how to solve cubics from C1, C2 or FSMQ. I don't believe this one has any exact factors that you would be expected to be able to find. So here it is. I wonder if you can find all the solutions, of which I won't tell you how many there are, by using, firstly, the right equation. There we go. By using your calculator and the process of iteration. And then maybe some of you might be able to go back to video number 8, where you might have found it difficult, and used the techniques you've used here, or learn here, to be able to answer that one. So good luck. Answers in the comments.